Hey guys, in today's video we'll be covering Unit 2.12 of the Math AA course, which is Polynomials. And this unit is HL only, so if you're SL you don't need to worry about this. But yeah, since this video is quite long, I have put some timestamps on screen right now, so you can skip to whatever part you want to work on. But disclaimer, I did make a mistake where I put 2.10 instead of 2.12 at the top of the screen. And again, yeah, that's a mistake. This is Unit 2.12, which is Polynomials. So first we'll start by defining polynomials. And polynomials are essentially functions where variables to the powers of different numbers are being added or subtracted together. So I'll put on some screen some functions which are all polynomials. And you've already seen these functions before, but what makes all of these functions polynomials? First of all, they all have variables, right? And that is your x here. So this is the number that's going to change as f of x changes. Now all of these variables have a number before them, and this number here is called your coefficient. Okay, so this is again the number before your variable. And now not every polynomial has this, but a lot of functions, not only polynomials, have a constant at the end, right? And this is the number that doesn't have an x next to it. It stays the same no matter how much the function changes. And now the defining feature, or the main feature of a polynomial, is the powers. So this power here, right? And for a function to be a polynomial, all the powers have to be natural numbers. So you can't have something, so you cannot have a number to the power of a square root, or to the power of a fraction, or to the power of a negative number. It has to be positive, full numbers for it to be considered a power or a polynomial. And now if you've noticed, I've made all of these variables here pink, right? And why is that? Well, these are the variables with the highest power in their function, right? So in the first function, it's x to the power of 1. 1 is the highest power. In the third function, it's x to the power of 3. 3 is the highest power. And this highest power here, we call the degree, or n function. So the first function here, n equals 1, right? The second function, n equals 2. And the third function, n equals 3, and so forth, right? N equals 4. And so we say the second function is to the second degree, and the third function is to the third degree, and so on and so forth. And each polynomial has a different name based on the degree of the polynomial. So if you have a polynomial to the first degree, we call it a linear. If you have to the second, a quadratic. Third is a cubic, fourth is a quartic, fifth is a quintic, and then a sextic, a septic, and so on and so forth, right? And we can generalize polynomials by writing them in this form. F of x equals an x to the power of n plus a n minus 1 x to the power of n minus 1 dot 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 plus a to the power of 0, right? Where x is here is your variable, n is your highest degree, and a of n is the coefficient of the nth term, right? And then a n minus 1 is the degree under 1. So if the function is to the fourth degree, n minus 1 is x to the power of 3, right? It's the x to the power of 3 term. And then finally you have your a to the power of 0, which is just your constant. And next move on to the algebra of polynomials. And the thing about polynomials is that they can be added, subtracted, multiplied, and divided by each other, right? So first we'll start by adding polynomials. So addition. And this is really simple. So the way you write it is just, if you have this f of x here and this g of x, and you wanted to add them together, you just do f of x plus g of x. And the way you do this is really simple. So let's have this down so I don't have to write it every time. And then you just add, so let's put this in brackets, plus 4x plus 1. Put this in brackets. So that's your f of x, your g of x. And all you do is you just combine the like terms, right? So you just have your 8x cubed minus 10x squared. The like terms combine and you'll have plus 5x. Like terms combine and you have plus 2, right? Pretty simple. And then we move on to the subtraction of polynomials. And this is pretty much the same as addition. But let's say this time you wanted to do f of x minus 3g of x. So you want it to minus 3 of them, not only one, right? So minus 3g of x. And the way you do this is, so you write the f of x down as normal, right? And then instead of just putting your minus g of x right away, you put your minus 3, and in brackets put your g of x. So now this 3 here is multiplied by every term in the brackets, right? So you just, first of all, expand the brackets. I'm not bring in the 3, plus 1 minus 12x minus 3, right? And then you just combine your like terms as usual. So this plus x and this minus 12x will combine to minus 11x, plus 1 minus 3 combine to minus 2, right? And then after that, we move on to multiplication. And again, this is pretty simple. So you just f of x multiplied by g of x. And again, you just put your f of x down as normal, right? Put it in brackets, put your g of x in brackets, and now we multiply them together. And you know that when you multiply two polynomials by each other, so this 4x here, you multiplied by this term, by this term, by this term, and by this term. This one you multiplied by here, 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 and here, right? You have to expand everything. So first you do 8x cubed times 4x, that'll give you 32x to the power of 4 minus 40x to the power of 3 plus 4x squared plus 4x. And then you do the plus 1, you bring in the plus 1, so plus 8x cubed minus 10x squared plus x plus 1, right? And then we just combine the like terms as usual. So it's 32x to the power of 4 stays the same. The minus 40 plus 8 becomes minus 32x to the power of 3. The plus 4 and the minus 10 will become minus 6 to the power of squared. Plus 4 plus 1 is plus 5x. You just have your plus 1 at the end, right? And finally, we have division, right? And this one will need a bit more space. I'll just take this all off. So division. Okay, let's say we have f of x and we want to divide this by g of x. All right, so the method we use is actually long division. If you're familiar with it, perfect. If you're not, I'll just go over it now real quick. So what you want to do first is you want to put your f of x function here. So make it nice and easy to read. And then you want to draw the long division symbol over it, which looks something like this, right? And what you want to do next is, let's actually move this to the side a bit. You want to take your g of x, the thing you're dividing by, and you want to put it right here. So 4x plus 1. It's nice to put it in brackets, makes it a bit easier. And actually, let me move this down a bit. And the first step in long division is you want to divide this number, so the highest term, or the highest degree in f of x, by the highest degree in g of x, right? So let's do it with this color here. So you want to do 8x cubed divided by 4x. And this will give you 2x squared, right? 2x squared. And then you want to take this number here and you want to put it above the term that you divided by. So you want to put it up here. And the next step is to take this number you just got and multiply it by everything in the g of x, okay? So when you multiply 2x squared by 4x, we already know that's 8x cubed. And 2x squared times 1 is 2x squared, right? We just put it here under the f of x. And what we do next is we subtract what we just got. We subtract this from this up here. Okay, so let's just draw a nice line here. 8x cubed minus 8x cubed is 0, right? Minus 10x squared minus 2x squared is minus 12x squared. And what we do next is we take this term here, this next term, and we just bring it down. We just move it down and put it here. Okay. And now we just repeat the first step, but with this number. So we divide this number by this number. So we'll have 12x squared divided by 4x. and that will give us 3x, right? Sorry, minus 12x squared, so minus 3x. And we just put that up here now, so minus 3x. And again, like what we did before, now we take this number and multiply it by everything here. So minus 3x times 4x is minus 12x squared, right? And minus 3x times 1 is minus 3x. And again, we take these two and we subtract them from each other. So minus 12x minus negative 12x will give you 0. And x minus minus 3x will give you plus 4x, right? And again, we bring this 1 here, just move it down. So plus 1. And we repeat again. We divide this by this, like how we did it before. So now we have 4x over 4x. And I'll just give you 1, right? So you take this 1 and just put it up here, plus 1. And again, you multiply this number, this 1 here, by everything in here. So 1 times 4x is just 4x. 1 times 1 is 1. Take these, subtract them from each other again, and that will give you 0 plus 0, which equals 0, right? So now everything's gone. So what's your answer? Well, it will just be this here. So f of x divided by g of x equals 2x squared minus 3 of x plus 1. And if you noticed, we got 0 down here, right? But this will not always be the case. Sometimes you'll get remainders. And I'll go over what that means next. And next we move on to theorems. And here there's two main theorems, the remainder theorem and the factor theorem. So we'll start with the remainder theorem, okay? So let's say we have these two functions here, f of x and g of x, and we want to divide them by each other, okay? So we use the same method we did last time, where long division. And since I already went over this last time, I want to explain my steps. I'll just go over it real quick. So this will be 4x squared minus 4x, subtract them from each other, plus 2x minus 2, subtract them, and you get 3, right? So f of x divided by g of x gives you this here, right? But last time we got a 0, this time we didn't get a 0, we got a 3. And what does this mean? Well, this 3 here is what we call the remainder, okay? Remainder, or r of x. And I'll show you why now. Now we have the remainder, right? And this number here, which we got, the answer, we call that the quotient, or q of x, okay? And now we have f of x, g of x, q of x, and the r of x. And basically what we can do is we can say that f of x, which is the first function, can be expressed as this product of g of x and q of x, right? Because if this divided by this gives this, then this multiplied by this gives this, right? However, we have a remainder. So what we do with this remainder? We just add it on the side here, right? And we can just prove this real quick, where f of x is 4x squared minus 2x plus 1. And we said this would be the product of x minus 1 and 4x plus 2, plus the remainder is 3. And we expand the brackets, we have 4x squared minus 4x plus 2x minus 2 plus 3. The remainder stays outside. And we combine all like terms and we have same equation, right? So what is the remainder theorem? Well, the remainder theorem states that if you're dividing a polynomial, so this one here, no matter the degree, by a linear function. So this here has to be a linear function, okay? And this linear function has to be in the form of x minus a, okay? If you divide a polynomial by a linear function in the form x minus a, then the function of a is your remainder. And what? Well, let's test it out real quick, right? So we have your f of x here, right? And we have our a, which would be 1 in this case. So let's do the function of 1. Okay, the function of 1. And this would be 4 multiplied by 1 squared minus 2 multiplied by 1 plus 1, which would be 4 minus 2 plus 1, which should give you 3. And you'll see that the result here is the remainder. It's the same. So if you're doing an assessment, if you're doing an exam, and you're given a huge polynomial, you're given like something to the power of 6 minus something to the power of 5, blah, 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 and you're asked to just find the remainder, you don't have to just go through this whole step to find the remainder. You can just plug in a here and just get an answer real quick. However, if you're also asked for the quotient, if you're asked for this number, you will have to do the long division. But if you're only asked for the remainder, you don't have to do division, you can just use the remainder theorem. And yeah, that's the remainder theorem. And next we move on to the next theorem, which is called the factor theorem. The factor theory. Okay. And this one states that, so here we said the f of a is the remainder, right? But if this remainder here is 0, if f of a is 0, then, so this x minus a here, or the thing being divided by, is a factor of f of x. And by that I mean the graph of f of x will touch the x-axis at x equals a, right? And we actually got an example of this in the last question we did here, where we got the remainder to be 0, right? So let's actually prove this using the factor theorem, or using the remainder theorem and proving that it equals 0. So first of all, you remember that we have to get this in the form x minus a, right? But here it's not x minus a, there's a coefficient before the x, we need to get rid of that. And the way we do that is we just move it outside the brackets. So we have 4x plus a quarter, right? We just moved the 4 out of the brackets. And now we have this x minus a over here. So we can just do this on the side to prove it. So the function of a here would be minus a quarter, right? And this would be 8 minus a quarter to the power of 3 minus 10 times negative a quarter squared minus a quarter plus 1. And you can just solve this manually, or you can just plug it into a calculator real quick, and you'll get your answer as 0. If you just put it into the calculator, you'll see that it equals 0, meaning that 4x plus 1 is a factor of 8x squared minus an x squared plus x plus 1, right? So this is your factor theorem here, and this is your remainder theorem. And you can just use them to quickly find out what the remainder is, or to find the factors of a polynomial, which we'll get to next. So next we move on to roots, zeros, and factors. And roots and zeros are essentially the points, the x-coordinates, when the graph crosses the x-axis, right? And if you remember for quadratics, we said that they can be expressed in the form f of x equals a x minus b1, x minus b2, where your b1, b2, where this b1, this b2 are the roots of the quadratic function, right? But this factorized form here, it doesn't only apply to quadratics, it applies to all different polynomials. And you can just keep going and adding more roots based on the degree of the polynomial, right? So you'll just have x minus bn. And n here indicates that the amount of roots you have, the amount of factors you have, is based on the degree of the polynomial. So when a quadratic, which is n equals 2, you have 2 roots, right? So you just had 2 of them for quadratics. If you had like n equals 5, you would have 5 roots, right? 5 roots. You would have 1, 2, 3, 4, 5, right? And now these roots here, they can come in different forms or different types, basically. First of all, these roots can either be real numbers or complex numbers, okay? And within these real roots, they can either be same or they can be distinct. And to give you a visual representation of this, we'll just go into some graphs that I drew, and we'll show you what different roots look like. So two rules to always remember is that a graph will have n roots and n minus 1 turning points. Okay, and I'll get to that right now. So this first graph here, right, it has one turning point, which means n equals 2, right? Because if there's one turning point, there's n minus 1 equals 1, n equals 2, right? And since there's two turning points, it means there has to be two roots in this graph. As you can see that the graph crosses the x-axis twice. So here you have two distinct roots, right? Two distinct real roots, because it does cross the x-axis and they're both different. Here, however, in the second graph, you again have one turning point, so n equals 2. However, the graph doesn't touch the x-axis, right? So it doesn't have any zeros. It doesn't touch the x-axis, which means that the graph has two complex roots, right? Two complex roots. And with complex roots, they're always going to come in even numbers. So you'll either have 2 complex, 4 complex, 6 complex. You'll never have an odd number of complex roots. They come in conjugate pairs, which you learned about in Unit 1. So anyways, you move onto this third graph where you have 2 turning points, which means n equals 3. And you see that, again, it crosses the x-axis only twice. So here you have one real root and 2 complex roots, right? One real, 2 complex, 3 roots. And we move on to this next graph here, where again, n equals 3. And it touches the x-axis here. And here, it touches the x-axis, but it doesn't switch. It doesn't go from above to below or from below to above. It stays on the same side. And when this happens, when it touches the x-axis and goes back up, this means that you have two same roots, okay? And this here would be one distinct root. And again, all of these roots are real roots. There's no complex. And then you move on here, you have 3 turning points, so n equals 4, touches the x-axis twice. So here you have 2 real distinct and 2 complex, right? And finally, this one here, again, n equals 4, but it doesn't touch the x-axis, which means that it's basically 4 complex roots. And this is just a visual representation of what your roots look like in different forms, right? So how do we find the values of these roots? How do we actually know what these roots are? Now, let's say we had this function here, right? And we want to express this function in this form. We want to put it as a product of its roots. How would we find what this b1, this b2, and this b3 equal? Now, again, since n equals 3, we do know that there's going to be 3 roots. And the process in finding the roots is, first of all, actually using the factor theorem and finding a value for x where this is going to equal 0. So which value of x will this equal 0? And we actually do this by trial and error. We just substitute random values of x until we finally get 0. And for this syllabus, you'll usually have a value of x between -2 to 2. So just try all the real numbers between -2 and 2 until you find which one works. Okay, so let's try first of all function of 1. That'll give us 1 minus 1 minus 8 plus 12, which would be 4. That's not what we're looking for, right? And function of 2 would be 8 minus 4 minus 16 plus 12, which is 0, right? So 2 here is b1. Okay, so now we know that if, let's say, we're going to write it here on the side, f of x equals, our first root is x minus 2, right? So how do we find the rest of them now? Well, what we do next is we actually use long division, which is a method we covered earlier in the video. And what we do is we divide this by this to find the other roots. Okay, so again, we put this here, draw the long division sign, put this inside, and we just go through the process of long division now, which is I covered earlier in the video. So if you're not sure what I'm doing now, just go back and find it. But basically, yeah, you just do long division, x squared minus 8x, so this has to be x, 6x plus 12, and hence this is minus 6. And your result has to be 0. There has to be no remainder, right? Because you're looking for roots. And roots or factors, sorry, it's always equals to 0. So now that you got this, what you basically know is that your function can now be written as f of x equals x minus 2 multiplied by x squared plus x minus 6, right? Because if this divided by this gives you this, then this multiplied by this gives you this, right? So here. And now you have your first linear function, or your first polynomial here, and now you have a quadratic. And what you want to do is you want to write this quadratic as two linears, right? And you can do that with the quadratic formula. You can just factorize normally. But if you do factorize, you'll find out that this can be factorized into x plus 3, x minus 2, right? Because plus 3 times minus 2 is minus 6, plus 3 minus 2 is 1. Okay, so basically, your function can be written as x minus 2, x plus 3, x minus 2, right? Now you have it in this form. However, you'll see that these two are the same, right? So you can just simplify this by putting them together and having x minus 2 squared multiplied by x plus 3. And since this is squared, now you know that your function has, so here it has two same roots, right? And one distinct. And these are all real. They're all real roots. You have no complex numbers. And yeah, that's how you find the roots of any polynomials. If, let's say, over here we got a quadratic, right? So it was easy to factorize. But let's say you got like x cubed. How would you factorize this? You do trial and error again with this to find another factor, and then go through the process again until they're all linear functions. Next, move on to the sum and product of roots. Okay, so if, as we said earlier, the generalized form of a polynomial is coefficient multiplied by x to the power of n plus the degree under, and so on and so forth until you have the constant, right? This is what we discussed before. And we already said in the past section that if this was a quadratic, it would have two roots, right? So if this was n equals 2, you'd have two roots. We'll say the roots are alpha and beta. If n was equal to 3, you'd have 3 roots, and if n is 4, you'd have 4 roots, and so on and so forth, right? So what we actually know, and this is given to you in the formula booklet, you don't need to know the proof as it is a bit complicated and beyond the scope of the syllabus. But basically, to make things easy, we'll just say there's two roots, right? Alpha and beta. What we know and what's given in the formula booklet is that alpha plus beta, the sum of the roots, is negative an minus 1 over an, right? So this an minus 1 here is this coefficient, and this an is this coefficient. And we also know that the product of the roots, so alpha multiplied by beta, equals minus 1 to the power of n times the constant over an. And this minus 1 to the power of n here basically means that if n is an odd number, so it's if 3, 5, 7, 9, whatever, this would be negative, okay? And if n is an even number, this would be positive. Okay, you don't need to know this minus 1 to the power of n, just know that if it's odd, it's negative, if it's even, it's positive. Pretty simple. And if this function had 3 roots, you just add this here, add this here. It doesn't really change anything in the formulas stay the same. So all you need to know is just, you have the formula, just plug in the values and you get your numbers. You don't need to know the proofs or anything. And you'll see how questions can be shaped around this. I'll do a past paper relating to this in the end of the video. So to finish off this video, I have 2 past paper questions which I want to solve. So this first one here is in 2 parts, and part 1 is you're given this function here, and it says that this x minus 4 is a function, hence find the value of k. And using the factor theory, we know that since x minus 4 is a factor, this means that the function of 4 should be 0, right? Using factor theory. And function of 4 is basically, this would be 3 times 4 cubed minus 11 times 4 squared plus 4k plus 8, and this should be 0, right? So 3 multiplied by 4 cubed would be 64 minus 11 times 16 plus 4k plus 8 equals 0. And here you just solve for k. So 3 times 64 would be 192 minus 11 times 16 would be 176 plus 4k plus 8 equals 0, right? Then combine the like terms, 4k, sorry. 4, 6, 16 plus 8 is 24 plus 4k equals 0. 4k equals minus 24 and k equals minus 6, right? It's the answer. So this here would be minus 6x, right? And hence or otherwise, factorize qx as a product of linear functions. And now we got the full function, we can actually linearize it or write it as a product of linear functions. And the first step is, I'll remove this. First things first, we want to do long division, right? We want to take this x minus 4 and we want to remove this from the equation, which is 3x cubed minus 11x squared minus 6k plus 8, right? We want to just solve this long division real quick. And again, 3x cubed divided by x would be 3x squared. Multiply this by the whole polynomial, you have 3x cubed minus 12x squared. Subtract, so then you get x squared minus 6x. Divide again, so that's plus x. X squared minus 4x. Subtract, so you get minus 2x plus 8. So this should be minus 2, right? To 0. So now you have it in the form of f of x equals x minus 4 multiplied by 3x squared plus x minus 2, right? And now we want to just linearize this quadratic here. We want to write it as the sum of 2 linear functions. And we can do this real quick by using the quadratic formula, which is x equals minus b plus or minus root b squared minus 4ac over 2a, right? So b is here, a is 3, b is 1, c is minus 2. So minus 1 plus or minus root 1 plus 24 over 6. X equals minus 1 plus or minus 5 over 6. So x equals minus 1 minus 5 would be minus 6 over 6, should be x equals minus 1, or x equals minus 1 plus 5 would be 4 over 6, which equals 2 over 3. So x equals 2 over 3, 3x equals 2, right? And here you can just write it as the sum of linear functions now, because you have your 2, x equals minus 1, 3x equals 2. So now you have equals x minus 4 multiplied by x plus 1, because this is x equals minus 1, and 3x minus 2, right? Pretty simple. So finally, we have this past paper question where we're given a quadratic, we're given the roots are alpha and beta, and using this information here, we're asked to find the value of k. Now, first things first, we know that the sum of the roots, so alpha plus beta, is the coefficient of the second highest degree divided by the coefficient of the highest degree. So this would be negative minus 2k over 1, which would just be 2k. Next, we know that the product of these roots, so alpha multiplied by beta, will give you the constant, which is, in this case, k minus 1, divided by coefficient of the highest degree, which is 1, and this is just k minus 1, right? Now, the trick here, and this will be used in most questions of this type, is you want to get a squared plus b squared, right? And the way you can get this is by taking alpha plus beta and squaring the entire binomial. And this will give you alpha squared plus beta squared plus the 2ab, right? Never forget the 2ab when you're expanding a binomial. And what we can do now is, first of all, this a squared plus b squared here, we know that that's 4. So this is 4. We also know that alpha plus beta is 2k. And we know that AB is k minus 1. So we just plug all these values in, and we have placed the alpha plus beta by 2k, and that is squared, equals, replace this by 4, and replace the AB by k minus 1, right? And we just simplify, so it's 4k squared equals 4 plus 2k minus 2, right? We can move everything to one side, so 4k squared minus 2k minus 2 equals 0. And then we can divide everything by 2 to make it easier. Minus k minus 1 equals 0. And now what we have here is a quadratic, right? We have a quadratic. And to find the value of k in a quadratic equal to 0, to find the roots, all we have to do is just use the quadratic formula. So k equals, b is minus 1, so negative that is 1, plus or minus 1 plus 8, right? Because I just plug in the values for the quadratic formula, and over 4. And then you just k equals 1 or plus or minus 3 over 4, which is k equals 4 over 4, or k equals minus 2 over 4. Therefore, k equals 1, and k equals negative a half. Pretty simple.